Welcome back. In the last video, we ran a code cell to get some data. Now, if you'd like, you can try to turn this into a Python script using what we're about to learn, but we also discussed that this is what we're working towards. We're working towards creating Python scripts, so the script mode notebook. So this section comes with two parts. We start with part one. We're trying to move towards part two. So let's keep pushing forward with that. We're up to part two of the cell mode notebook. Create datasets and data loaders. So we've got a dataset over here, which is in standard image classification format. And in the previous section, section 04, we learned how we can use Torch Vision datasets and transforms to load in our data in its current form and turn it into datasets. We also learned that we can turn our datasets into data loaders. However, we've written code like this before. So wouldn't it be good if we could functionize this or turn it into a Python script that we could reuse? So let's just run this and see what happens. Shift and enter, shift and enter. We can get the class names. We can get a class dictionary if we want. We can check the length and we can turn train and test datasets into data loaders. Wonderful. And then we can check out a single image size and shape. So let's have a look at how we could go modular with this particular section. Let's create section 2.1, and this is going to be a script for create data sets and data loaders script mode. Now, I want to emphasize that this is only one way of creating a script like we're doing here. So we could just copy this into a python.py file, but there's a Jupyter magic command called write file that we're going to use. So I'll just write this down. So let's use the Jupyter magic function to create a .py file for creating data loaders. So let's look this up. Jupyter cell magic. And if you're wondering why am I using Jupyter, not Google Colab? Well, Google Colab runs a version of Jupyter under the hood. So Jupyter notebooks are a very popular way to run different data science code. And Google Colab builds on top of Jupyter, which is why if you save your notebook, it saves it as an IPyNB. Jupyter, before it was called Jupyter, was called IPython. But it's now a Jupyter notebook, Colab notebook, same thing, just running in different areas. So built-in magic commands. Notice that there are magics here with a single percentage sign, that's a line magic. And then I believe if we look up the double percentage sign, what do we have here? Are we going to get, cell magics. So a cell magic runs in the whole cell. So if we look up percentage write file, here we go. Write the contents of the cell to a file. That's exactly what we want. So what are we trying to do? We're trying to save our most useful code cells to reusable Python scripts. So we can save a code cell's contents to a file using the Jupyter magic. Now let's write in write file, and then it's going to be file name after that. Beautiful. So let's see this in practice. How about we create a file? We write a file called, we're going to save it to a going modular directory, and we're going to go data setup.py. Now, I just want to re-highlight the fact that we're turning this code here into a Python script. And if you're wondering where this code came from, create datasets and data loaders. If we go back to Notebook 04, we loaded in image data using image folder, and then we created the datasets there, and then we turn in the data loaders there. So that's where this code came from. We're just going to get out of that, so we have less tabs open. Let's see what we can do here, hey? How about at the top of the file, we write a doc string, which explains what the file will do. Functionality for creating PyTorch data loaders, and for image classification data. So this is going to appear at the top of our .py file, and it tells anyone who uses it that, hey, this is what this file does. So let's start off. We need to import the same things that we have here. So we need to copy this from Torch Vision datasets, import datasets and transforms. Wonderful. And we need to also import data loader, because this is going into a Python script. So our Python script needs all of the modules that our scripts have access to. And there's one more thing that we're going to use, which is import OS. We'll see where that comes into play in a second. Or actually, how about we just do it right now? Num workers equals os.cpu count. Beautiful. So let's keep pushing forward. We're going to go def create data loaders. Now this is going to be a function that we can use to create our data loaders. So let's put some inputs to this function. We want it to look up a training directory. This can be a string. We want it to also look up a testing directory path. This can also be a string. And then we'll pass in a transform to transform our data in some way, shape, or form. And we want to let it know that it's a composition of transforms from the transforms library. What else would we need? Maybe a batch size. This can be an integer. And then finally, let's set num workers for the data loaders to be an int, and we'll set it to num workers. So num workers is just going to be however many CPUs we have access to. So if we were to run this, get rid of this line, otherwise it's going to save it to file. Num workers is 2 in the case of Google Colab. It might be more if you're using num workers /os.cpu count on your local machine. So let's just get rid of this and see what happens if we just run this. Oh, no such file or directory going modular. Well, what we're going to have to do is create a directory for going modular scripts. So we could of course come over here and add a file, but let's just create one using code. We're going to go os make dirs going modular. We're going to store all of our scripts here. So if we have a look, going modular, that's all we created. This is going to be empty now. And that's why we got that error, because going modular didn't exist. So let's run this and see what happens. Oh, look at that. We've written our first Python script, albeit it doesn't do too much. Let's have a look. Going modular, data setup.py. Look at that. That is the power of this Jupyter magic. We write this line and then we get this. So you can imagine later on, if we have some useful code and we want to write it to file, we can use this line here. So let's complete this file setup, hey? We'll get rid of that and we'll get rid of this. Let's just go back to finishing off this. We'll write a doc string here. I'm going to spend a bit of time on this first one, writing a doc string, just so you can see what it's like. Testing data loaders. Maybe I'll leave that as a challenge to you. And I'm using Google's style guide for Python. We've covered this before, briefly mentioned it. But if you're writing a function, oh, we're going to have a lot of, we search for doc string. Yeah, comments and doc strings. Here we go. This is your extra curriculum. To read up how you should structure the doc strings of your functions, this is Google's style guide. You don't necessarily have to use this. It's just, I find it fairly easy to read, and you might see it in a fair few places where Python scripts are written. So this is what we did at the start of our module. And if you're working with functions and methods, you can write args, returns, raises. So we have one line at the top of our function describing exactly what the function does. We can describe it a little bit longer here. We can type in what args it takes, so arguments here, table handle, explain what that is. Then we have returns, what comes out of it. So in this case, a dictionary comes out and it looks like this. So that's what we're going to replicate for our function here. Let's go back. Takes in a training directory and testing directory path and turns them into PyTorch datasets, and then into PyTorch data loaders. And that line is a bit too long for Python, so we're just going to enter that. Beautiful. And now, what args do we take? Let's write in here, traindir, which is the path to training directory. So all I'm doing is writing information about traindir and testdir and the arguments that our function takes here. Testdir, path to testing directory. Now this is important to do not only for people that you share your code with, because that's what you eventually want to do, right? Is write code that's so good you can share it with others, but it's also for your future self. What if you were to look up some code that you've written a few months ago and you don't know what's going on? So this is transform to perform on the training and testing data. You can customize, this is important to know, you can customize these functions however which way you want. What I am writing now is just one way of doing things. So batch size is going to be number of samples per batch in each of the data loaders. And then finally, we're going to set num workers, which will be an integer for number of workers per data loader. And then finally, we can type out returns. What do we get from this? A tuple of, we're going to get a train data loader back. We're also going to get a test data loader. And we're also going to get class names. Beautiful. We'll just explain what class names is. Class names is a list of the target classes. And after we write the example usage, we'll finish this video off so it doesn't get too long. And then I'll set you the challenge of actually writing the entire function here by condensing the code that we've got, the train data loaders and the dataset creation and the transformation creation. I think you can do this. Once we have the example usage down, that'll be your challenge for this notebook. So train data loader, test data loader, class names equals, we want to create a function here called create data loaders like we've written above. Traindir equals the path to the train directory. And then the testdir, I might just tab across here. Testdir equals path to testdir, where the test data is. And then transform equals some transform that you can create. Let's say the batch size is by default 32, and then the num workers, let's just say that's 4. But we've already hard-coded num workers, so we don't necessarily have to do that. So give that a go. Down here, by the end, it should return train data loader, test data loader, and class names. So in here, it's going to be some code. So that's your challenge for this video. To prevent it from getting too long, what we're doing is we're turning this code, data loaders and data set, into a Python script called datasetup.py. And what we just did was we wrote a doc string, so if someone uses our code in the future, or we do, in Google style, they know what's going on and they have an example of what happens. So give that a go, write in the code there, and we'll do it together in the next video.